Dear students, I am Santa, working as a physics faculty in Target English Medium School. Today in this part video, I would like to explain or teach what is the velocity or speed of sound and what are the standard values, what are the values of velocity of sound in different medium. In soft is nothing but like in solids, liquids, gases, etc. And also what is the relation between temperature and velocity. These topics mostly we discussed in this part video from the chapter of sound in 8th standard level. Now let me start our topic. Okay. Velocity or speed of sound. Velocity or speed of sound. So it is also one of the terms involved in the sound concept. So I said very clearly, so some of the important terms involved in the sound, that is frequency, amplitude, time period, wavelength and velocity of the sound. So in our previous video about the four, okay, is nothing but frequency, time period, amplitude and wavelength. I will explain clearly. Now in this time we continue for that one, velocity or velocity or speed of sound. Velocity of sound. Velocity or speed instead of the one. Velocity of sound. This is our. The distance traveled or covered by a wave in a unit time is called velocity of the sound. Listen very carefully. So the wave is either transverse or longitudinal wave, but the wave is from the starting point. Okay, in a unit time, it is covered how much distance, that is means. So the either transverse or longitudinal wave from the starting point in a particular unit time, it is traveled how much distance or it is covered how much distance. So that is simply we are called velocity or speed of the sound. What is the formula to find? Same as velocity is equals to, okay, wavelength upon the time. Actually this one, distance is nothing but the distance traveled by the wave is nothing but wavelength. We know that simply. That's why, so velocity is nothing but the distance traveled by a wave in a unit time. Velocity is equals to wavelength upon time. This is the formula. Wavelength upon time. So why wavelength upon the time means simply here. The distance traveled by a wave or the distance between two successive crests or trough is nothing but it is a complete wave. That's why that is simply what we are called wavelength. Velocity is equals to wavelength upon the time is nothing but distance upon the time, or it is simply we can write it lambda upon t. Lambda upon t. Lambda is nothing but wavelength, t is the time. That is the formula of velocity of sound. You can find the velocity of sound by using the resonant curve air operator method. Okay, that experiments we are doing in intermediate second year level in the practicals. By using the resonance air column operator, we can find what is the speed of the sound in air. That's why, anyway, so some operators are there to find or to find the velocity of sound in the different mediums. So now, velocity of sound is maximum in solids. Example, for example, aluminium. (6430 meters per second at 25 degrees Celsius). Nearly 6430 meter per second at 25 degrees Celsius, because of velocity is equals to distance upon time or wavelength upon time. Wavelength is measured in meters, time is measured in second according to SI unit. Velocity of sound is moderate in liquids. Example, water. Nearly 1531 meter per second at 25 degrees Celsius. Next, third one. Velocity of sound is minimum in gases. Example, an example. Air is 336 meters per second. 346 meter per second. Where at 25 degrees Celsius. But at the 0 degree Celsius, its value is 331.4 meters per second. That is equals to 331 meters per second or 330. So that's why you are observing that the scientists have find out that by using the various instruments, the velocity of sound is maximum in where solids. Moderate is nothing but it is not higher than solid. It is so means the velocity of the sound is lower than the solids and higher than the gases. That's why velocity of sound is moderate in liquids. For example, water 1531 meters per second. Velocity of sound is minimum in the gases. For example, air 346 meters per second. Here temperature is constant, but in the solids, for example, aluminium. Aluminium is a solid metal. We know that. What is its value? 6430. Water is a liquid, its value 1531. Gas is a air 346. That's why speed of the sound is maximum in the solids, moderate in the liquids, and lesser in the gases. Next one we discussed. The relation between temperature and velocity of sound. The relation between temperature and velocity of sound. If temperature increases, velocity or speed of sound is also increases. Listen very carefully. If temperature is increases, velocity of sound is also increases. How means simply only one thing. If temperature is increases, kinetic energy of molecules is nothing but the molecules is absorb the heat energy by supplying of that one. When they absorb the heat energy, their motion is increases. So simply motion is nothing but kinetic energy. If it means the energy possessed by a body due to its motion is called kinetic energy. That's why listen very carefully. When the particles are absorb the heat energy, then what will be happen means the intermolecular space is slightly increases. That's why they have the more space to attain the maximum energy. Due to that one, what we discuss that simply for understanding of it in your standard level. If temperature is increases, the kinetic energy of the molecules or particles is also increases in a medium. If the kinetic energy is increases is nothing but velocity increases because of mass of the particles are constant. What is the formula of kinetic energy? Kinetic energy is equals to half mv square. Mass of the particles are constant. Half is the numerical value constant. What is that one? Velocity. That's why kinetic energy is inversely proportional to the square of the velocity. If kinetic energy is increases, velocity is also increases. That's why if the temperature is increases, the kinetic energy of the particles or molecules is also increases in a medium. Then velocity is also increases. That's why if temperature is increases, velocity or speed of the sound is also increases. But how we can find? For example, 1 degree temperature is increases in the atmosphere. Then how much sound speed of the sound is increases? That is one. For that one formula is there. So V of T is equals to 331 point or V equals to 331.4 meters per second plus 0.6 into T of C. This is the formula. This is the formula. Or we can write V of T is equals to V plus 0.6 meter per second into Tc. So means V is nothing but velocity of the sound at 0 degrees Celsius in the air. That is the meaning. So the velocity of the sound at a particular temperature. This is it. V of T also we done. V of T means temperature. Velocity of the sound at a particular temperature. You can find 331.4 meter per second because of at 0 degrees Celsius. This is the common value plus 0.6 into T of C. 0.6 meter per second. Why 0.6 here we have written means for every 1 degree Celsius temperature is increasing in the atmosphere, the speed of the molecules is increases to how much one? 0.6 meter per second. Listen very carefully. For every 1 degree Celsius rise of temperature, the speed or velocity of the sound particles are increases how much one? 0.6. Means simply 1 degree Celsius is increases to which one? Increases to 0.6 meter per second. It is the temperature, it is the velocity. That's why for every 1 degree Celsius rise of temperature, 0.6 meters means that much of velocity of the particles are means velocity of the particles is increases to 0.6. Initially, velocity of the particles are just 1 meter per second at 0 degree Celsius. Next, at 1 degree Celsius, what is the velocity of the particle? 0.6 increases is nothing but 1.6 meter per second. So anyway, so the temperature is increases, velocity of the sound is also increases. What is the reason means I explained. If the temperature is increases, kinetic energy of the particles or molecules is also increases. If kinetic energy is increases, velocity is also increases because kinetic energy is directly proportional to the square of the velocity. So that temperature increases, indirectly. So speed or velocity of the particles is also increases. But what is the speed of the, or what is the formula to find velocity of the sound at a particular temperature? Means V of t is equals to 331.4 meter per second plus 0.6 meter per second T of C. T of C means the temperature. What is the temperature? We can set that. This is simply we can also write V of t is equals to V. V means velocity of the sound at 0 degrees Celsius plus 0.6 meter per second T of C. I will tell one simple example for this one about this. It is very important. That's why keep in your memory. So simply, what is the velocity of sound at 20 degrees Celsius? Simply. So one numerical, it is just like about previous one. What is the velocity of sound at 20 degrees Celsius? That's why V of t, velocity of the sound at temperature, which one? 20 degrees. What is the formula? 331.4 plus 0.6 into T of C, temperature in the degree Celsius. But what is the 20? This is the way. That's why V of t or V is equals to 331.4 plus 2 6 12. That's why 12. Then what is this value? 331.4. So 4, 3. That's why 343.4 meter per second. So the speed of the sound at 0 degrees Celsius is 331.4 meter per second. But the speed of the sound at 20 degrees Celsius, what is the value? 343.4 meter per second. That's why you are, I hope everyone will understand this. Temperature is increases, speed of the sound is also increases because of kinetic energy of the particles is increases. And one more important thing is also we discuss in this time, that is what is the relation between velocity of sound, frequency and wavelength. So it is very, very important for big purpose or for one mark purpose anyone. What is the relation between velocity or speed of the sound, frequency and wavelength? So we know that what is the formula of velocity? V is equals to distance covered by the wavelength is nothing but lambda upon t time. That is we know very clearly. That's why V equals to lambda upon t. So this is, we should write V equals to 1 upon t into lambda. We can write like this one. So lambda upon t, I should write 1 by t into lambda. Finally lambda upon t. Then V is equals to, okay, nu lambda, because since here 1 by t is equals to f. Already I said in the frequency concept, the number of vibrations made by a vibrating body in 1 second is called frequency. Then frequency equals to number of vibrations upon 1 second, or frequency equals to 1 vibration by t. That's why 1 by t is equals to f, is nothing but frequency. So frequency means we can write in that one, or nu we can write the frequency. So frequency means we denoted by different symbols f or n or nu. That's why v equals to nu lambda, or this is also we can write that, or v equals to n lambda, or next v equals to f lambda, anyone. So v equals to nu lambda, or v equals to n lambda, or v equals to f lambda, anyone. So mainly this is the formula, or this is gives the relation between velocity of sound, frequency and wavelength. Listen very carefully. The relation between velocity of sound, frequency and wavelength. So we know that velocity is equals to distance traveled by a wave in per unit time. So distance traveled by the wave is nothing but lambda and t. So then v equals to lambda upon t, we can write 1 upon t into lambda. Then v equals to 1 by t means nu or frequency. That's right, nu lambda. V is the velocity, nu is the frequency, lambda is the wavelength. That's why this formula gives the relation between velocity, frequency and wavelength of the sound. Thank you.